Yes, welcome back to Easy Gates, Gate 22 Easy memory-based questions and solutions. Okay, let us get into the next problem. The next problem is from analog electronics. 1 minute. Yes, that's a problem. So that's a problem figure, and hope I got the data correct. So given RD of 4 kilo ohm and RS of 1 kilo ohm, given that the NMOS in the given circuit or in the given amplified circuit is operating in saturation. That means that the VDD given and VGG given are biasing the NMOS comfortably and operating in saturation region of operation. That means what we need to do in the circuit means we need to find out the ratio VA by VB. The ratio between VA and VB is a numerical answer type problem for 2 marks. Okay, that means what we have to do exactly in the circuit means, so given already the NMOS is in saturation, you have to get the small signal equivalent of NMOS and begin a comfortable small signal AC analysis. Find the ratio VA by VB. That's all. Okay. Yes. So then what is the small signal equivalent of NMOS? So the given NMOS, usually NMOS will have this characteristics. Beyond the threshold, it is operational and it is biased at some Q point, IDQ, and then this is VGSQ. So for around the Q point, if you offer a small swing, then it is going to offer the small signal source resistance or small signal equivalent RS, which is nothing but 1 by G. That means there is going to be a transconductance. The transconductance is going to be change in ID, small change in ID as a result of small change in VGS. Okay, that's a small signal parameter GM. So with this GM, you have to begin your analysis, but it is not given. Okay, so the small signal equivalent of NMOS will be this. Hope you are familiar with this. So this is your drain terminal, this is your source terminal, this is your gate terminal. Just before your source terminal, bring the small RS into the play. Either you can use small RS or you can also use 1 by GM. Okay, so let me do the AC analysis using small RS model of NMOS. Okay, small signal AC equivalent of NMOS. This is your AC voltage VGS. And this is your AC current ID. That's all. So VGS by ID will be your small RS. That's our transconductance. Okay, now let us begin the small signal AC analysis. Problem belong to only the small signal AC analysis. The goal is to find the value of VA. That means expression for VA and expression for VB. Then we'll go for the ratio between VA and VB. We'll get the answer easily. Okay, so it's a AC analysis. So there is nothing to do in the DC analysis because given device is already in saturation. Okay, maybe threshold value given, but it is not into the, since we are not doing a DC analysis, we need not to consider the given the data which are given belong to the DC analysis. Fine, let us begin the AC analysis straight away. It's a small signal AC analysis, remember. So you have to switch off. Let me have a copy of the circuit. So let us switch off the DC sources. VDD should be made 0 because we are about to begin the AC analysis. Then switch off this VGG as well. Okay, then you have to replace your NMOS by its small signal equivalent. So remember, this is your source, this is your drain, and this is your gate. So in the gate, you're going to apply your AC potential. Okay, for the small signal AC analysis. Okay, so then what will be the small signal equivalent of the circuit? Let's see. Then the small signal equivalent will have the entire AC signal at the gate. Then we have the NMOS, small signal equivalent of NMOS, small RS. Remember, this is your source terminal, this is your drain terminal. So here we need to connect that external resistor RD that is equal to 4 kilo ohm given. Then VDD is made 0, so it's connected to ground. And here we have the capital RS, that is equal to 2 kilo ohm. Okay, yes. And this is what exactly the terminals where we need to find the voltages VA and VB. Okay, we are not looking for VA and VB value. We're looking for only the ratio between them. That's a comfortable small signal AC equivalent. With that, we'll begin a comfortable AC analysis. So AC analysis begins for the value VA by VB. Okay. So the plan is, let us find the expressions for VA and expression for VB. Okay, VA and VB. And as per the small signal equivalent, remember that this potential difference is 0. Okay, I'm not teaching this fundamental. Yes, take this granted. So this is VG, but remember this is your AC voltage VGS, but always there is a VGS, small VGS existing between gate and source. But I'm not talking about VGS equal to 0. I'm not saying VGS equal to 0. This difference between these 2 points, this point is internal and people used to call this as VS cap. That is exactly equal to VG as per the small signal equivalent. So no voltage difference. Okay. So taking the 0 will make a rapid AC circuit rapid AC analysis for this NMOS amplifier. So this is VN. VG is exactly equal to VN means this potential also equal to what? VN. If that is the case, what is your AC drain current or drain to source current in the channel? So what is ID? Small ID. Small ID is going to be VN divided by small rs plus capital RS. That's as simple as this. Okay. Then what do you want? You need VB. So then find out the drop across this. What is that? It's going to be ID into RS. So it's plus minus. So this bottom is 0. You can happily say VB is equal to 0 plus voltage across this 2K. That is going to be ID into RS. Okay. And similarly, let us find VA. For that, you need this current. So what is this current? This is still the channel current. This is still going to be ID. And this is going to make a drop across this as what? ID into small ID into RD. So strictly as an analog circuit engineer, you have to use only the small letters for representing voltages and currents during small signal AC analysis. Hope you have that habit. I'll go by that only. And but given capital VA, V suffix A and V suffix B, so I am forced to use a capital letter here. Okay, so but still take this granted because it is given. So take this way. But whenever you are assuming something, you go by strictly small letters. Now the goal is to find VA. So what is the top potential here? 0. And the current is down. Therefore, you're going to lose this drop from 0 volt. That means your VA is equal to what? 0 minus what? ID into RD. Let me straight away write it's minus ID into RD. So this drop is going to be, that means the point potential at the drain terminal is going to be your VA. That is going to be minus RD into RD. Yes, problem is almost over. Okay, you can sense the root from now. Yes, what is that? We are looking for the value VA by VB. Then simply go for the ratio. ID will get what? Cancel if you go for the ratio. Then simply the answer is going to be minus RD by capital RS. So RD is given, RS is given. So it's going to be minus 4 kilo ohm divided by 2 kilo ohm. Okay. So it's almost like the NMOS doing the current transfer from the source to the drain and neglecting your effect of RS. Okay, so but he is not going for the voltage gain. Okay, it's going for only the ratio between the drain voltage and the source voltage. That's all. It is going to be minus RD by RS. Therefore, the answer is going to be minus 2.0. If it is up to 1 decimal places, if it is up to 2 decimal places, your answer must be minus 2.00. That's a perfect answer for this problem. Exploiting a very simple basic of AC analysis of NMOS transistor. Okay. So this is the reason, okay, why I used to say this problem is this paper, gate 22 ECE paper is simpler, easier comparing to gate 21 paper. Probably the cutoff will definitely raise to around 35. Okay, that's my anticipation. Okay, we'll see. Okay, what is exactly the cutoff after the result? Okay, yes, I have used almost the data given in the gate paper. If any change, the structure of the problem is same. Okay, if any data change for RD and RS, answer will change. Okay, but anyway, that's a way to get the answer. If I am all right with the RD taken and RS taken, that is exactly your answer. Okay, I hope the numbers are perfectly all right. The perfect answer for this problem is minus 2.00. Maybe you'll come to know the actual problems. Okay, by 15th when the response sheets are out. Okay. Yes, thanks for watching. Do subscribe our channel. We'll update you with one more interesting problem happened in K22 ECE paper. Okay. Yes.